Welcome to our video. Let us introduce to you about our project, Sign Language Detection and Recognition. We are Team Roy 1. We have been working so hard to develop a comprehensive solution for both continuous and static sign language recognition. And we aim to make the hearing-impaired individuals easier integrating into our normal society. Today, we give you a quick overview about how our project developed, the challenges we overcome, and what we learned over the last 2 semesters.
Our continual sign language recognition system uses multiple heuristic to convert sign language video into a sequence data. We initially used LSTM, which showed a promising results on a small dataset of 3 classes. Hello, I love you, and thanks. However, to improve our model, we switched to the more recognized WLESL dataset. We then compared LSTM and transformer with the self-attention. LSTM suffered from training oscillation and reached an accuracy of 14%. In contrast, the transformer with self-attention achieved 45% accuracy on WLESL 10 classes.
For static sign language recognition, we want to use CNN to classify the sign language images in the beginning of our project. And we have also did an experiment using ResNet 15. Unfortunately, the dataset we found is only contains the images of hand, but the input that we actually use through the computer camera is the upper body of the user and his hand. So, there is a mismatch between the input of the training site and the input of the real use. At the same time, to achieve real-time recognition, we expect that the algorithm should have the ability to classify 30 images in 1 second, but the classification speed of ResNet 15 does not meet our needs. Therefore, after our study, we chose ULV5. It can locate the hand position in the whole images by bounding boxes, and classify the gesture only based on the image content inside bounding boxes, without focusing on other parts of the input images, which can be reduce the noise. However, after the experiment, we found that ULV5 has difficulties in classifying similar hand gesture. At this point, we need an algorithm that enhances the features of hands. And this is why we use midi-pipe hands to mark a point to the hand and enhance hand features. After our real use, using midi-pipe hands can improve ULV5's performance in sign language recognition. Especially can let ULV5 to know the difference relations between the different fingers.
Our initial journey on the web development was not easy. Initially, our goal was to achieve real-time recognition on the web, and we used OpenCV to display the result on the website. However, we soon realized that this approach was not user-friendly, as every user needs to have OpenCV installed on their device to use our website. So, to address this issue, we looked for an alternative approach. Eventually, we found a solution that involved transmitting the result from OpenCV firm by firm for the backend. This means that OpenCV only needs to deploy on the backend to free our user from the need for any hardware configuration. As a result, they could easily access the recognition result on the front end without any additional software installation.
Here is our conclusion and future work. In this video, we'll give you a quick overview about our project, and we hope our work can contribute to making communication more accessible for everyone. Thank you for watching, and we look forward to sharing our progress again.